Hello everyone, this video I will show you our new product, that is KinCony M30. The M30 made by ESP32 module is an AC energy meter. So that totally have 30 channel current of the CT clamp and 3 channel monitor the AC voltage. And this board also made by ESP32. You can integrate to Home Assistant by ESPHome very easily. Because we have designed the YAML file and uploaded to our website, you can download and direct it to use. And later I will show you how it works in Home Assistant. And this board, you can see, also have 30 channel of RGB LED. So we have make new innovation in this board that every channel of load will have one RGB LED. So the RGB LED is colorful, so that if the load current is very high, so the LED will be turned red. And if the load current is very small or very low, so the color will be green. So that have many different levels of color, and just according to different load current. So let's look at this M30 hardware details. Okay, you can see this is our KinCony website that have M30. You can see the picture of the M30 made by ESP32 module. And this we have used this energy meter IoT chip, that is BL0910 chip. This is high quality of the energy meter. So that we have used 3 picks of this chip and manage 30 channel of the current and the voltage incoming. And this we have used ARM CPU. The ARM CPU will read different data from all this chip, IoT chip. And you can see this we have designed support 4G module so that you can connect to your cloud server without Wi-Fi, without Ethernet, just by SIM card by 4G. And here you can see our PCB board. Later I will show you the active just this PCB board details. And you can see the appearance of the box, and you can see that have 30 channel of CT clamp sensor. So just connect it here. And this you can see the board also support DC 12 to 24 volt power supply. And you can see that have colorful LED for different load. Okay, let's look at this PCB board in details. Okay, let's look at this M30. This is AC energy meter, and this appearance also made by Amelia. You can see it here. And this board also you can see support install on the DIN rail in your power distribution box. And here you can see this is Wi-Fi antenna. And if you have the 4G module, you want to install this SIM card and use the 4G module. And this have a hole. You can install another Wi-Fi extended antenna at here. So that is for 4G by this module. Okay, let's look at the PCB inside of the box. Okay, let's look at this M30 PCB in front of side, and this is the back in front. And you can see that is the terminal for DC power supply and RS485 interface, and this is I2C extender. And this made by the ESP32. You can see this have a IPX Wi-Fi extender antenna, and the Ethernet and the USB, and this have 2 buttons. This one button is EN, that means reset. This is reset, ESP32 reset, and this is download. And also you can define by yourself, just GPL 0 is this button. And you can see here that have 3 channel of voltage monitor from 0 to 380 max volt. So maybe you have 3 phase, so phase A, phase B, and phase C. So you can monitor the 3-phase voltage. If you have used the single phase, so you can just use only one of the voltage detect channel. And this is have the 10 channel of CT clamp input. This is another 10 channel, another 10 channels. So total have 30 channel of CT clamp. So just use this one, CT clamp. And this you can see 1, 2, 3, the 3 energy meter chip. So you can see it here, that is BL0910. So this is high accuracy data for the energy meter. So, and this have an ARM CPU. This is ARM CPU. And we have designed this CPU and to read 3 chips data to here, and feedback to ESP32, and feedback to RS485 interface. So this have connect with this ARM CPU by the serial port, and also this have connect with this RS485 by serial port, because the chip have multi-serial port. And this is SD card. If you want to save some data by yourself, you can insert a SD card, just a TF card, and save the data inside of the card. And this is for the 4G module socket. And you can see we have used this SIM7600 4G module, and you can connect to this socket and use the external, this is the Wi-Fi antenna, and install into your box. So this can send your energy meter data to your own cloud server by yourself, according to your data. And this time you can see we have designed this RGB LED. This is WS2812, the RGB colorful LEDs. So maybe you can set this is RGB LED strip, and actually you can control every channel, just every one RGB LED. So that the different, such as the channel 1 of CT clamp, and this LED will change the color. And every channel will have work independently with a different color for different input of the CT clamp. So this is very useful, just easy to understand which load is high and which load is low current. So you can see this is our PCB design. And then next, I will show you how it works in Home Assistant. Okay, let's look at the M30, how it works in Home Assistant. And you can see this is my computer. And in this Home Assistant web page, we have created the M30 dashboard. And in this dashboard, you can see the M30 have the current from 1, 2, 3, 4 until 30. You can see it here. 30, the third chip of 30, just the last one. And you can see every channel we have current and energy, power consumed, and you can see the energy sum, just the total power consumed, and this is the frequency, the power frequency. And this is the temperature of the IoT chip. And this is the voltage we have detected. We have connected the AC 220 volt. Actually, this is 240 voltage. And this is the power watt for this channel 1, channel 2, because this meter is new, so this is 0. And you can see the second chip, just the 11 channel. And you can see the totally have so much channel of the current and the voltage and the power consumer and the frequency and the temperature. This is for the load detect. And this we have added this 30 LED indicate, and different LED indicate that will have a colorful changed by the load. Later I will show you how it works. And also you can use Home Assistant to control it in different color. And this YAML file we have configured, you can download from our KinCony form. You can see this is M30 that have a config YAML file for ESPHome. And you can see this also supported by modbus port. If you have used this one, USB convert to RS485 connect to the board directly. You can work without Home Assistant, without ESPHome, just read by modbus protocol directly. So this is used by the modbus port PC software and read all data from the M30. And you can see this is a YAML file. Now I have set every 5 seconds to update the date. So you will see in Home Assistant that the date will update in every 5 seconds. Okay, let's power on of our load and show you how it works. Okay, let's look at this warmer heat. We will test just as a load. And this you can see this M30 that have turn green because no load is power on. So this is turn green because the mobile phone camera is not clearly to see the color. Actually, this is turn green. And I have used this this socket. I have connected it by the CT claim. So this socket, the power you can come from this line, just from this power incoming. This is AC 220 volt and to this socket, and this one is connected with my warmer heat. Just later I will power on and change the temperature. And this power detect I have connected with this terminal. You can see this terminal is from monitor the AC power. So I have monitored the 220 volt at here. And this CT claim, I have connected with this channel 1. You can see this is CT1, positive and negative. Just use this 2-1. This 2-1 have connected with the CT sensor. And the CT sensor maybe have this socket. I just cut it. So I just connect to this terminal directly. And this multimeter, I have detect ampere. You can see, detect the ampere and connect with this, the socket's power current. Because I need to compare this value and with my Home Assistant, detect the value whether it's correct. So this for the ampere. And this multimeter, I will test the voltage. So you can see I have used the voltage as a voltage type, just this one voltage. Later I will show you how it works. Okay, I will detect it. So you can see I can power on. Let's power on. Let's look at this is 0.21 ampere. Let's look at the Home Assistant. And you can see in my Home Assistant that is 0.22 because this date is every 5 seconds update. So this will be slowly, and because this multimeter is real time update the state. So you can compare the date and to the Home Assistant dashboard. And now you can see we have detected the AC voltage is this value you can see at here. And now I will use the multimeter to detect the voltage. So now I can use this multimeter. Will detect the power just at here. And you can see I can detect it. This is the voltage. And please compare with the Home Assistant. And you can see this is the voltage have detect. Look at my Home Assistant. The value almost is seen. And now we will detect the current. You can see at here, this is current. You can compare this value with our multimeter. And you can see this is 0.21. And this you can see 0.21, almost the same. And now I will change it. You can see I can press this, the function is changed. And the current you can see it become high. And also you can see this is 4.6. And this LED you can see that have changed a little color. That is a little yellow. And this is the value of the current, and you can compare with our multimeter. And you can see this is the current 4.61. And let's look at this one, 4.66. Just a little difference. It's normal. So you can see 4.66. And this is 4.6. Okay, let's begin high. I can change it. You can see this is very hot now. And you can see the current, the color is changed. You can see this LED is turned red. So now it's very hot. This is very hot. And this one, you can see the current is become large. 8.6. And let's look at the Home Assistant. You can see 8.6. And this you can see is turned red. This turned red. So you can see this value is changed almost everything as this one. You can see everything as this one. 8.5 ampere. You can see 8.5 ampere. Okay, this is turned red. And now you can see the red. Now I can close it. Power off. And you can see turn green. And this is the low current. And also you can see in my Home Assistant that is become low current. Okay, this you can see we have detected the current and detected the voltage and by this M30. So you can connect with many different channels and monitor by the Ethernet in Home Assistant, and also use the modbus protocol. You can integrate with the PLC or other device just by the USB converter to IS485. So that will be very useful. Okay, thanks for watching.